The screen is visible.
Yes, sir.
So we had an introduction on the roof. Just a quick recap. So we told the roof is the uppermost part of the building, and it protects the building from all type of weather conditions. And we have different types of roofs. What are the various requirements of good roof? Should protect the building first of all, and other important uh, requirements of the roof. We classified the roofs into sloping roof, flat roof, and the curved roof. So where we propose or where we choose the flat roof, where we choose the pitched roof, and shell and folded plate were discussed, and we had a detailed investigation or a detailed study regarding the pitched roof. I told you the angle of inclination should be more than 10 degree. It can be high as 45 to 60 degree, and the various uh, type of roof coverings, and we learned about the pitched roof, this inclined roof, different types of roof, lean to roof, as the figure indicates, lean to roof, lean to roof, then the gable roof having inclination to both sides, then we had the hip roof having inclination to all the sides, gambrel roof, mansard roof having change in slope along a single direction, and the deck roof, topmost place flattened. And we had some discussions on the lean to roof that shows gable roof, double inclination, hip roof, four inclination, gamble roof, change in slope, and the mansard roof, similar to hip roof, and the various important terminologies in the roof, such as what is called as a ridge, topmost portion, what is a valley. Valley is the that like a valley portion is there, a sunk portion is there. What is a gable end? What is lean to roof? What is a ridge? What are eaves? What are hips? What is a hip end? So and so. Uh, okay, this we will study when the course goes on. Uh, so the pitched roofs, uh, they are more they're most preferred if the span of roof is less than 5 meter. So if the span of roof is 5 meter, less than 5 meter, we prefer the single roofs, which comes under the pitched roofs. And the various types include lean to roof, coupled roof, coupled close roof, collar beam roof, collar and scissor roof. In all these roofs, rafters are placed at 600 mm to 800 mm spacing and are provided as main members. So this takeaway is the rafters are the main load carrying members, and the battens run perpendicular to the rafter for placing the roof covering. We'll see what is rafter. So in this figure, this is a lean to roof. So the roof is leaned or it's joined with the main wall, and we can see common rafter. So this is the common rafter. It's a main load carrying member in the roof, and above the rafter you have some perpendicular members, which is called as the what's it name? They're called as the battens. Okay, battens are perpendicular to the rafter. It is meant for placing the roof covering over the rafters. So we have roof covering, gutter for the like um, collecting all the rainwater and to take it out, and we have the string course, not important. Wall plate is the uh, like this not a member, it's a facility provided at the joining between the main wall and the rafter, so that it will be remains in this angle. for support. And we have corbel as a structural member for placing the rafter onto the main wall, and knee strap for joining it with the minor wall. So this is the simplest form of a pitched roof. In this type, one wall is carried up sufficiently higher. So this is the main wall, which is tall, and the other one is given to give the necessary slope to the roof, the veranda wall. The rafters are suitably secured on the wall plates and eaves boards. Battens and roof covering are provided as shown. So this is the arrangement. And this type of lean-to roof are preferred for sheds, outhouses attached to main buildings, verandas, etc. Then we have the coupled roof. So on comparison with the previous one, having only one way or one side slope, here we have two-way slope. So in this type of roof, the common rafter, so here also the rafter is the main load carrying member. This is the rafter, and above the rafter you have the battens and the roof covering. So this common rafters slope upwards from the opposite walls, and they meet at a ridge piece. So both the rafters are joining at the central portion called as the ridge piece in the middle as shown in the figure. The common rafters are firmly secured in position at both the ends. One end bearing on the ridge piece and other on the wall plate. So these rafters are joined one on one location at the ridge piece and then at the wall plate one and they are mostly used for span up to 3.60 meter. Then, okay, so previous one was coupled roof. So this is coupled closed roof. So this is the one which makes the roof closed, the tie beam. This roof is similar to the coupled roof except that the legs of common rafter is connected by a tie. So previously we had this rafters just fixing to the wall plate. By providing a tie between the bottom legs of the rafter, which will make the roof more stable, and it prevents spread out and overturning of the wall. So this make the truss itself a closed stable member. So this can be used for span up to 4.2. Previously it was 3.6. So for more span, should provide a tie beam. It's the main takeaway. And then you have the collar beam roof. So compared to the previous one, when the tie beam is lifted up, okay, so the tie beam is provided at a high elevation. So this roof is variation of the coupled closed roof. The tie beam is raised and placed at a higher level. The tie beam is known as the collar or collar beam. So when this type of beams are called as the collar beam. Okay, on the level of the wall, it is called as tie beam. When it's raised, it is called as the collar beam. And by providing a highly elevated collar beam, the peasants or will get more workspace here compared to the previous one. So collar beam is adopted to economize the space and increase the height of the room. The collar beam is usually fixed at 1/3 to 1/2 of the vertical height from the ridge. So the location of the collar plate, so the collar beam, and suitability, they can be adopted up to a maximum span of 4.8 meter. Okay, next is collar and scissor roof. You can clearly see the difference. They're providing a scissor joining between the rafters, rafter 1 and rafter 2. This roof is similar to the collar beam roof, except that two collar beams which are crossing each other to present an appearance of scissors. So which look like the scissors. So collar and scissors roof. The next one is double or purlin roofs. So these are provided for most spans. If the span exceeds, the cost of rafters increase and single roof becomes uneconomical. For spans more than 5 meters, double purlin roofs are preferred. The intermediate support is given to rafters by purlins, support over the collar beams. So we have the collar beams here. Figure shows a typical double or purlin roof. So the main thing is that once the span of the roof is very high, you will be providing purlin which is perpendicular to the rafter. So the purlins will run perpendicular to the screen. So maybe at various points, and this purlins will support the rafter so that the bending of the rafters are minimized. I hope it's clear. The purlins are provided perpendicular to the rafter. Rafter is in this angle, and the purlins will be provided maybe at here, one here, and here, which will support the rafter. And the other main one is the truss roof. So if the span is more, you have to go for the truss roof. These frames are called as trusses, and we can see the various type of trusses. Okay, these are well established shapes of the various trusses. Those include the king post truss, and this type of configuration of truss can be used up to span of 8 meters, having a outer triangle and one vertical and 2 inclined members for the king post. And if you want to increase the span from 8 meter to 10 meter, you have to go for the queen post trusses. A span is basically, the distance between the end to end. So for 8 to 10 meter, the most preferable truss is queen post truss. And the other established truss models include the Howe truss with 4 and 8 panels. So the number of panels. So this is a panel 1, 2, 3, 4. So the number of panels and the span is interrelated. So if you want to go for 30 meters, you have to go for more number of panels. Similar to the Howe truss, we have the Pratt truss. Then we have the Ferk or French roof trusses. So these are various arrangements of members within a truss. So it depends on the designer and the aesthetics to choose which is good. And also the connection is also important. That requires some experience to choose the more apt one. Then for very high span from 20 meter to 30 meter ranges, you go for a compound French truss having this configuration. And you can also go for cambered French roof truss. Then we have the fan truss having for the span between 10 meter and 15 meter, and the north light roof truss. This is also very commonly used one. Then we have the quadrangular trusses. So this type of trusses are mostly seen in the workshop or some godowns. Quadrangular truss, and the trusses used for large spans. This is also well seen in large storage houses. And for very long one, maybe beyond 30 meters, you have to go for a combination of various trusses. So those about the trusses, well-established configuration of the trusses. And next is about the shell shell element or shell members as the roofs. So you can see maybe in some above the mosque, you can see some shell roof. So the shell roof are defined as the curved surface where the thickness of the shell is very small compared to the other dimension. That means comparing with the diameter or the total perimeter of this um, shell, the thickness will be very small. So once suppose in this shell we are applying some load, the members, the structure won't bend. Instead of that, the load is transferred from maybe at the any point to the support through the membrane action. That means along the curved surface. So in these roofs, the load is transferred by membrane compression instead of bending. Okay, you should note that in previous cases here also the members are taking load by either tension or compression. There is no bending happening here by tension or compression. But in this case, there will be some bending for the rafters. So this is bending type of load transfer. By in this case, only tension and compression in the members, and in the case of shell, only by the membrane compression. And the various types of shells include cylindrical shell, uh, cylindrical along the length. Then we have the butterfly for some cycle shed, paraboloid, ellipsoidal, north light, spherical dome. So there are various well established shell roofs configurations. What is the advantages and disadvantages of shell roofs? So as you know, the shell roofs are selected because they are good from aesthetic point of view, and the material consumption is very less. It is very thin member which cover the larger area. And other advantage is the formwork can be removed very early because mostly the member will be under the membrane compression, so there won't be any bending in the shell. So the formwork for making this shell can be removed very early, and very large column free areas can be covered by the shell roofs. Disadvantage include a top surface is covered. As it is curved, we can't use it like a terrace. And the form work for making this one is very costly. Even you can remove it very fastly, and other material economization is there, but for making the form work, it is little bit costly. So so we learned about the pitched roof, uh, like single sloped roof, then the trusses, then the shell roof, and the last one is the flat roof. So like flat roof is just a flat roof. Maybe for a single story building, you can see having very reflective roof. And generally, for the flat roof, the slope, the angle between uh, the horizontal and the inclination of the roof should not be more than 10 degrees. And this small angle is provided for facilitating the draining out of the water. The advantages of flat roofs are the roof can be used as a terrace for playing and celebrating function, for any other function purposes, and any at any later stage the roof can be converted to a floor by adding another story. We can keep on increasing the story, also provide like that the current roof will be a floor for the next extension. They can suit to any shape of the building. So for any type of building is fine. Then the overhead water tanks and other services can be located above this flat roof. They can be made fireproof easily compared to the pitched roof. Because you can provide the fireproof coatings easily. There are some Disadvantages for the flat roofs, like they cannot cover large column free areas. Shell can cover large column free areas, but the flat roofs has got some limitations. The leakage problem may occur at lateral date also due to the development of the cracks. So crack formation is a problem, and once the leakage problem starts, it needs costly treatments. The dead weight of the flat roof is very high, and in places of snowfall, the flat roof has to be avoided because it will keep on adding the load onto the flat roof. The next one is the initial cost of construction is more for the flat roof, and the speed of construction of flat roof is less because we can't remove the formwork as quickly as for the shell. So by these classes we had an introduction to the various type of roofs and the members, and in detail we will look in the next class.